Okay, so we gave a couple of minutes um, just for the sake of time, and we value all our attendant. Um, we don't want to waste your time, so let's kick off the session today. Hi, everyone. This is Juan Pérez Mar. I'm part of the marketing team, and I'm happy to be back here to host this tech dive session together with my colleague Enrique. So he's solution architect at Barbara, and today we will be presenting. We will be focusing on one of the use cases that is, let's say, getting more relevance in among our users, which is unified namespaces. But as usual, Enrique will show all the details about the platform, so you all get familiar with it in case you are not. So, Enrique, happy to see you again around.
Thank you, Juan. Thank you. So, well, let's start then. Okay. I need to share my screen. I think, Juan, you have to grant me for sharing the
I
screen.
have just did that, so you should be able to do it now. Just for the record of everyone, I'm recording this session, so we will share it afterwards to everyone, not only you, but also those people who weren't able to attend. And I will be making some, from time to time, comments on the chat to give you more information or complementary information to what Enrique will be showing. Just check your chat and feel free to send your questions through the question and answer section or through the chat directly. I will be reading them afterwards once when Enrique is back.
Okay. Okay, so let's start then with this session on February. The tech dive, as you know, is a session that try to help you to understand how the Barbara platform works. Okay. We normally see a couple of use cases. Today we are going to focus on one of them, which is the unified namespace, but we'll see also another one related to computer vision. Then we'll review an overview of the platform. Here we have the full agenda. Okay, so we will start explaining what the Edge AI is and why it is necessary. What are the advantage of using the Edge instead of using the cloud. Okay, then we will focus on this couple of solutions. I want to show to you. The first one, UNS, quite popular nowadays. Okay, and we will see how can we implement an example of UNS, okay, in using Barbara Panel and the application that are available in our marketplace. And then we will see also a use case for covering a computer vision solution, okay, in which we will get information from a video camera, we will analyze it using an AI model, and then we will make some detections on the video. We will save all the data in a local storage in the edge node, okay? And then in the third part, we will just have an overview of all the possibilities that the platform offers to you. Okay, so that is the agenda we are going to cover today. And well, let's start directly and let's see why the Edge AI is. Okay, well, it is very simple. At the end, the Edge AI is a technology that helps you to remotely deploy, run, and manage application and AI model directly on distributed on-premises devices instead of relying on the cloud. So, in short words, this is basically moving your workload from the cloud to machines that are located in the edge. And when we speak about the edge, we are referring to this area near where the data is being generated. Okay, so normally we have some devices that can be physical devices that but also can be virtual machine deployed on these customer facilities near where the data is being generated. So we can deploy application on those devices to run the workloads there instead of running on the cloud. Okay, so that is the HAI. That is the concept about the technology, and that is specifically what Barbara can help you to do. Okay, we can help you to manage this application. We can help you to manage this edge node in a very simple way, in the same way as you were using the cloud. Okay, so or what are the advantages of using the edge instead of using the cloud? Okay, until now, until the present time, it was common to have all your workloads from the cloud around everything there. Why should we move this workload to the edge, okay, and run the application on the edge? We have here four basic keys or a reason why it is necessary to move your workloads from one side to the other. Okay, so the first one is cost. Okay, obviously, the cost of using the cloud depends on the amount of data and the amount of resources you need to use, and it really depends on every use case. But for example, think about what we are going to cover today, which is a computer vision solution. Imagine you have to move all your video stream to the cloud to process them there. Okay, it is really, really costly. Okay, so the cost is basically one of the reasons why you should move all these processes to the edge. Okay, because at the edge, all the costs are predictable. Okay, so you will have no surprises. Second reason why you should be moving all these processes to the edge is also the security. Okay, and well, I won't say that the edge is more secure than the cloud because everybody can say, okay, my cloud solution is really secure. I have my own security, rules, so everything is protected. Okay, that is and understandable. But at the end, check this is a good number we have here. 61% of the cloud services received attack during 224. The attacks are targeting the cloud, okay, specifically. So when you put these workloads on the edge, just because everybody is focusing on the cloud, the edge is more protected and it's more secure by design. Okay, at the end, it is also hidden behind the corporate firewall, and it's also compliant with the OT security of the enterprise. So normally, the data there is more protected than in the cloud. Okay, but this third point is very important, the privacy, because this is one of the most important reasons. If you want to keep your data privacy, you cannot move it to anywhere else, okay? So the best way is processing the data just near where it is being generated, inside the customer facilities, okay? So this way, when you are using the cloud, you need to move your data, your OT data, your industrial data to the cloud, and that is something that normally the industrial customer don't want to do. Okay, that is why the edge is better to process everything there without leaving our customer premises. Okay, we have also a fourth reason here, which is friendly. Okay, normally the cloud tools have this kind of IT software interface with command line, with black string, with complex JSON configuration, all this kind of thing that normally require some IT skills. Okay. On the other hand, a platform like Barbara, which manage the edge, is has a much more user-friendly interface. Okay, so you will see it when we start showing the platform, but the interface we have in Barbara doesn't need this type of high skill related to IT. Okay, I will also mention a 5 point here that it is not described in this slide, but I will also mention the latency. Okay, and the video computer vision is also a good example for explaining that. Normally, when you are deploying one of these use cases like a computer vision, you need to detect something on a video and you need to take some action. You need to do it quick. Okay, so if you have to send the data to the cloud, analyze everything there, and wait until the answer is received, it would take some time. Okay, so if you need high latency, you will need to use the HAI because it is much more quick because everything is processed just near the sensors, so it is much quicker. Okay, so well, these are the what we say the key factor for moving your application, your workload in general, your AI model from the cloud to the edge. Okay, so well, let's continue then. Here I have a diagram that reflects how the Barbara platform is organized. Okay, and it is really simple, but it shows perfectly what it does. Okay, so Barbara platform, as we mentioned at the beginning, it is an orchestration platform. So it allows you to manage edge devices, manage this kind of hardware or virtual machine that are located in our customer premises, but it can also allow you to orchestrate all the workloads, all the application and AI models that are deployed and running on this edge node. Okay, so here we can see one of these edge nodes. Okay, again, physical device or virtual machine located in the customer facility. It must be running this product here, the Barbara core. Okay, this one. Okay, the Barbara core is the first product I want to mention for the Barbara platform. Is an operating system developed internally in Barbara and designed to be cyber secure. Okay, from the very first minute. So that means once you install this firmware in the edge node, you will have no open port, no SSH access, no admin or root user. All your files will be encrypted. You will have TPM support. You will have secure boot, outgoing and secure communication. I don't know, a lot of different cybersecurity measurements that make this device to be compliant with the AIC 62443 specification for cybersecurity in industrial environments. Okay, so it saves you a lot of time. You don't have to install the device and then send someone there to protect everything, to close the port. No, everything is done once you install it. So you can just install the OS and start working with that. Okay, because when you install the firmware, this equipment connects automatically with our API. And about the API, we have the other two products I want to mention. Okay, the first one is Panel, and Panel is basically the interface we will use for managing everything in Barbara, both the devices and the applications. Okay, and then we have the Marketplace, and the Marketplace is just an application hub containing over 150 different applications ready to be deployed on the edge node. Okay, well, check this plane we have here, because this plane separate what we call the orchestration plane from the solution plane. Okay, Barbara lives on the orchestration plane. What does it mean? That means that in Barbara panel you will see data about your devices, their status, their health, the application that are running there, the logs, the configuration of that application, but you will never see any user related data. Okay, why not? Because this data live at this side of the plane, in the solution plane. The industrial data, the user data, is managed by the application that we deploy using Barbara. Okay, but that is a very important concept because we are completely isolating the user data from the Barbara platform. So that make also your data to be more private. Okay. Well, that is the way we work. We just select application from the marketplace, we deploy them on an edge node, so that way we can use this application to read the data, store locally, process it, have some visualization dashboard, applying some AI model, whatever is necessary to cover different use cases and different architectures. Okay. Before finishing with the slide, I would like to mention that the platform can be deployed either on cloud, okay, and we have the SaaS version of the platform, and we are going to be using that today in the demos. But we can also provide an on-prem installation, okay? So it is also very common that some of our customers want to have an on-prem installation of the Barbara platform, because that way, if the platform is installed in any internal data center for our customer, the communication between the platform and the device doesn't leave the customer premises, so everything is internal, okay? And this is something they require, right? So this is the way Barbara is organized. I want to show you this another diagram that helps you understand how is everything managed. Okay, so we can see here we have panel, we have marketplace. They are on cloud. We're using the SaaS version. Okay, at this level, we can access this platform or this interface is using any browser, as we are going to do today. But this way, we can select application from the marketplace. We can use panel to send them to the edge node that you can see. So Barbara Core is orchestrating all these applications that can be deployed using panel and selected using marketplace. So this way, I can deploy anything that comes from the marketplace, but also user application and user AI models, as we will see in some minute, and I can access them remotely. I can access them locally, okay, from the field. If I connect any equipment from the field, I will be able to access this application, but also I can access them remotely using an internal VPN that is available in Barbara. Okay, so we can see it also later. So this way check how many possibilities we have for creating different architectures. Okay. Well, that is all I wanted to say from the HAI point of view. So now that we know the advantage of using the HAI, now that we know how Barbara is working and how can it help us to deploy this architecture, let's see a couple of examples. Okay. So I will start, well, I will start showing this slide because it define what kind of solution we can deploy using Barbara. I would say we can deploy anything using Barbara, okay? But we have like five group of solution that are quite popular among our customers, starting from data operations and unified namespaces. This kind of data collection use cases where normally the goal is get all the data from all the equipment and all the process available in a company and make them available to be processed and to get value from them. Okay, so from very basic data collection use case to a complete unified namespace, as we are going to see today, this is the first option. Then we have the predictive analytic, in which we go one step forward. We have the data, but now we are also going to apply some AI model to get some value from that data or to determine which action should I take when analyzing the data. Okay. Then we have the third part of the solution, which is the computer vision, normally solution that requires to work with video data, to video stream. Okay. They need normally more powerful devices with GPU, this kind of hardware, but at the end, it is quite similar. Just getting data, analyzing them, and taking and getting value and possible action to be taken. Okay. Then we have the software-defined automation that are normally well solution. That makes or have the possibility to use virtualized devices. Okay, for example, we have in the marketplace some virtual PLCs or virtual RTUs in the case of a smart grid system that normally were hardware. Okay, were equipment that had their own hardware and they were a box that you put somewhere that now can be virtualized. Okay, so now we can deploy a software that makes any device behave like an RTU or like a PLC or whatever. So it is also one of the example we have for solution. And finally, the cybersecurity. Okay, we have also some possibility to when we have the edge node in a network, we can deploy this kind of normally AI powered solution that analyze all the traffic in the network and predicts if there is any risk of we are receiving any attack, any abnormal behavior in the network. So all this kind of solution related to cybersecurity and network security are also available. Okay, so these are the kind of solution that are more popular when you're using Barbara. But as I mentioned before, we can deploy anything and we can create any architecture necessary because that is the nature of the platform, really, really flexible and modular. Okay, so well, when we have seen that, let's start speaking a little bit about UNS. Okay, so what is UNS? It's a really common term, really popular nowadays. The meaning is unified namespaces. Okay, but what is that? Okay, let's start by the very beginning. And this is something we have heard from our customer that they say, okay, my data is very valuable, but it is inconsistent, it is hard to scale, I don't know how to get the maximum value for all the data, okay? Because, there are some reasons that make this use case difficult to achieve. Okay, the first one is data trapped in silos. Normally, in a company, you have several locations with different technologies, with different places. Okay, so normally you can have some data extraction or data collection, but they are just in a location. Okay, so moving all the data to a central point without having silos is not something easy to do. Okay, that is one of the goals that UNS wants to achieve. Okay, the other one is data spaghetti. Okay, it's also very normal that you have different data sources. Okay, so when you have one new system that needs some data, you make the direct connection from the data generator to the system. So that way you are like creating point-to-point connection between system and data generator and data sensor. And at the end, you have this kind of data spaghetti architecture where you have different links for different purposes, not related one to the other. So that makes all the management of this connection is quite a nightmare. Okay, there is also some question related to poor data quality issues. Okay, so it is very common in this kind of situation that you have some missing data or you have data that is being duplicated. You have the same data into side, or you are naming the data in a different way, which you are reading it here or you are reading it there. So you have this kind of inconsistencies or gaps that reduce truths and limit how the data can be reused. Okay. Then this is also a very important point that is common for all of our customers. There is a heterogeneous and legacy system. Okay, we have a mix of brand new system with new protocol, with new functionalities, mixed with really old and legacy equipment that use legacy protocol. So you have to mix them together. You cannot replace everything. Okay, you have to get the most from the system you have. So Barbara will help you to get the data from both kind of equipment, the modern one and the old one. There is no problem about that. Okay, there is also some manual cleaning and contextualization. It is funny, but it happened. Okay, people spend time exporting, fixing, and labeling data instead of using it. Okay, yes, I have the data, but the data is incorrectly named. It has wrong format or it's not normalized. So this is a lot of tax, a lot of work to be done in that way. So using UNS, you will avoid doing that. Okay, and finally, and this is one of the target that UNS has, is having a single source of truth. Also, it's common here when you don't have the UNS that you get the data from one sensor and you send it to a system, then you have a second system connected to the first one that read all the data and put it here also. So you at the end you're having like different databases with the same information here and here, so you don't have a single source of truth. That is something that we need to avoid using UNS. So at the end, we want to have only a single source of truth, to have all the data in a normalized way, in a standard way, in a single point. So all the systems that need to read data can access the same result. Okay, so that is exactly the philosophy behind UNS, and this is explained in this diagram. Okay, so we have before this management nightmare where you have different location with different equipment, different data, and instead of having this point-to-point connection where there's a poor cybersecurity, there's some data spaghetti, are the heterogeneous system, and at the end you are having like conflicting or data conflicts here, or you have like different databases with this not a single source of truth. You move from this situation to this one where you have just one single source of truth. Okay, you receive all the data in a contextualized and standardized way, okay, from all your location without having silos. Okay, so this way you can access this single source of truth from all the system you have, any solution you may have, Okay, this way all your data will be all together and accessible, okay? And we offer at Barbara, using this search orchestration, a centralized management to perform all this tasks together, okay? So, what are the benefits of using Barbara in this case of UNS solution, okay? Well, we mentioned it before. It is built for heterogeneous and legacy industries. We can adapt to any existing database sensor system. Is no problem. We can read data from anywhere. We can process it, filter it, cleaning it, and send it to any single source of truth. Okay. We mentioned it also before. We are OT friendly and cyber secure by design, because we are using our own OS. I mentioned before we are cyber secure. Okay, and also the interface you will use for deploying all this application is OT friendly. You don't need this high IT skills. Okay, then we have an open and ecosystem driven. We are open and ecosystem driven. Sorry, so we can integrate with any existing tool and partner. Okay, but we also provide our own marketplace, our own application for the marketplace to add all the functionalities you may lack in your existing system. And well, the platform is designed for scale and evolution. Okay, so you can start small, dealing with the data of a single point, and then you can scale to cover all your needs. Okay, so that makes Barbara the right tool for this kind of UNS architecture. Let's go now to the point. Okay, I will show you one example of UNS in the platform, and for that we are going to use this architecture we are seeing here. Right, we have this different levels, okay, in which we have from the field level, okay, where we have all the sensor. We are going to simulate a food and beverage plant, okay, in which we have like different plants. In a plant, we have different lines, okay, developing different products, okay. So we can see we will have a field level where all these sensors and machines are connected. Normally, they're in the line, okay. This can be like the level one of the Purdue model, okay. Then we have this line level, okay. In the line level, we will have normally one edge node. This box we have here is an edge node that is connected to the line one, okay. We have another edge node connected to the line two, another edge node connected to the line N. It's available, okay. So we have one edge node getting all the information from all the machines and sensors that are integrating the line. Okay, so all this data will be consolidated here, filter, name in this edge node. Okay, we will also have a local storage here and even a visualization dashboard at bit level. But all this information will go northbound to the next level, which is the side level. We will have another edge node at the side level that is receiving all the information from all the lines in this side. Okay, so again, it consolidates all the information and make everything standard, and then it sends all the information again to the enterprise level where we have all the information for all the company. Okay, and then here normally is where we have this single source of truth, this kind of database or data foundation where everything is being consolidated. Okay, so this is the general architecture we have. We are going to see a simple use case in which we have only one enterprise, obviously, one site and two lines. Okay, and this is the architecture we are going to deploy. Okay, we have the line level, we have the field level where we have different sensor PLCs or other equipment. We are going to use an OPC UA connector. Okay, this is the edge node in the line level. So we are going to deploy an OPC UA connector in this edge node to read all the information from this equipment. It will be publishing all the data to this MQTT broker. It is a special broker we have, okay, because this broker is also translating all the information to the Sparkplug format, which is a standard format to make or to help us to standardize all the format that we are using in the MQTT broker. Okay, so This way, we can store all the information also in a local InfluxDB database and having a local Grafana. Okay, so we can see all the information from our line locally here. But this MQTT broker is also bridges to the next level where all the information goes. And finally, it reaches this enterprise level. Now, what we have in this example, just as an example, is an ignition instance that is reading all the information from this broker. Okay, and we have here some dashboard to visualize all the information from the different lines. Okay, so it is just an example. We could use different databases. We could use different connectors. You could use Modbus or Bagnet or 7 or whatever. We can adapt to any existing legacy or new equipment here. So it is really, really flexible. Now, what we are going to do is just moving to the platform. Okay. And let's see this example in here in panel. Okay, so now I have a lot of different devices here, but I have a group created for this UNS solution. Okay, this is the group. We have 4 edge nodes here. We have an edge node in the line 1, an edge node in the line 2, then we have another edge node at the site level, and finally one more on the enterprise level. Okay, so we are going to see one by one all this level. So let's start here in the line 1. Okay, we have an edge node, and we can see in this part, application and model, that we have some application deployed. Okay, let's start by this one. Okay, this is the OPC UA connector. This is the application that is reading all the information from the sensors. Okay, so how is that? We have this configuration here. It's a JSON-based configuration. Okay, where we are declaring where is the URL of the OPC UA server. Okay, that is getting all the information from the equipment in the line. Okay, so we can here declare what is the name of the device I am reading, how often do I want to refresh the information, okay, in this case 5 seconds, what is the area, what is the line 1 in this case, and then I can also declare the name of every variable, the namespace, the type. Okay, so here is where I am defining this naming convention. Okay, I am declaring what I want to read and how will I name it. Okay, so that way I can use exactly the same variable here and there. Okay, so this is the way of connecting to this OPC UA server, and this OPC UA connector is sending all the information to this MQTT Sparkplug broker we have here. Okay, so this is the broker that is receiving all the information from this connector, and it's also translating the information to the Sparkplug format. In fact, we can connect here. Okay, and let's see how is the information we are receiving from the connector. Okay, we can see in the network card that we have this VPN IP, so I can use this IP and this MQTT broker just to connect to the broker we have. I am connecting to this application here, to this broker, okay, using this tool. So here I can see that I have some messages from line 1, okay, with the energy consumption, alarm status, I don't know, we have some other equipment, the oven, with the temperature of the oven. So all this information is what we are getting from the OPC UA connector, from this OPC UA server connected to the sensor and to the equipment, right? But this is, let's say, the raw information. But at the same time, every time I receive one of these messages, this broker automatically publish also the translation of the same message using now the Sparkplug format. Okay, the Sparkplug format has one advantage, that it is compatible with almost everything. Okay, but it has some disadvantage that it uses a binary format, non-readable for humans, as you can see. Okay, but at the end you are having the same information in both formats. Okay, and as you can see here, we are having all the information from line 1. Okay, so well, this is what's happening on the message broker level here, but then we will see that you have also uh, the InfluxDB database with an ingester that is reading the information from the broker and storing it here in the database. And we have also the Grafana that is showing the dashboard with all the information. So let's review that, okay? We have here the InfluxDB, okay? We have the ingester that is moving all the information from the broker to the InfluxDB. And we have also this Grafana that we can use for visualizing all this information in this edge node. That you can see, we can use the same IP I used before with the VPN to access remotely the service in this device. And here I have all the information for all the machines in line one, as you can see, with the resource energy consumption, with the alarm status, everything is here, okay? So, well, that is the dashboard for the line one. We have something very similar in the line two. Okay, before changing check, we have a couple of more applications, the Node-RED and the Alert Manager. Well, they are just making some processing with the data. Okay, we can use this Node-RED to get the data from the MQTT broker and process it somehow to get some value and publish back the result to the Node-RED. So this way it is also reaching the InfluxDB and the Grafana. Okay, the Alarm Manager is an application we have in our marketplace, and it is really, really useful because it allows us to read all the information that is being managed by an edge node. So we can select a variable, we can put threshold to that variable, and every time the information exceeds the threshold, we will receive a notification in the channel we have selected. Okay, for example, Telegram or mail or whatever. Okay, so it is a way of having alert whenever there is a situation we want to be notified about. Okay, and it can also check the health of the other services. So in case, for example, there is a problem with the InfluxDB and the service is down, we will also receive a notification indicating that there is something we should check. Okay, so well, this is line one. Okay, if we go back and check line two, we have more or less the same. Okay, we will see that we have, in this case, we have less application. We just have an OPC UA connector. In this case, this connector is reading the equipment in line 2, as you can see, different equipment and different variable, but very similar. And then we have the InfluxDB and the broker and the ingestor. Okay, so in this case, we are not having a Grafana, for example, but the structure is exactly the same. And in fact, we could connect to this broker also, and we can see that in this broker, what we have is the information about line 2. Okay, so this is the information we are receiving from line 2. Okay, well, once we have that, okay, let's go to the site level. And the site level is just the level where line 1 and line 2 converges. Okay, so you will see here we just have one simple application, which is the MQTT Sparkplug broker. Okay, we are at this level. Okay, so in the site level, we just need this application. So let's move to the next level, which is the enterprise level. And here we will receive all the information from the site, which is line 1 and line 2, and it will be all connected to the Ignition instance, so we can see all this dashboard with all the information together. So let's move here. Let's connect to this broker. Okay. And we will see that now, if we go back to the enterprise level, we can use the IP from this hash node to connect here. And now we can see that in this MQTT broker we have in this enterprise level, we are receiving the information from line 1, but also from line 2. Okay. We are receiving both information together. Okay. And once we have all the information here at this level, we can go here and we have also the Ignition instance, okay, that is connected to the broker to have all this visualization dashboard. So we can access to this instance using the IP of the VPN, okay, so this way I just open this application in the Ignition gateway, right? and I will see this single source of truth with all the information standardized and available for any other equipment. Okay. So, well, project is starting, and here we will see the information from line one. Okay, as you can see, we have all the machine in line one with the values and also the information on line two, as you can see. Okay, so, well, this is a example of how can you deploy this kind of UNS solutions, okay, in an easy way. We have been using just this architecture with this application, but as we mentioned before, we can adapt to any existing system, we can adapt to any existing equipment. So it is just an example of how thing can be done. Okay, so the point here are no silos, standard information, standard naming convention, and single source of truth. Okay, so this is what I wanted to show you about the UNS example. I don't know if there is any question available. Yes, Juan?
Hi, Enrique. Hi, Enrique. I have one question here in the chat. It's related Ignition. You used Ignition as part of the implementation, the UNS implementation. Is that the question is if it's that the only tool that you can use for visualizing data?
No, 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 obviously no. We can adapt or we can choose some other possibilities. At the end, what we need is in a standard, it's a single source of truth. Okay, so we can use any database. We can use, for example, I don't know, a Splunk database in the cloud or in the data center. We can use anything that is available in the market. So it is just an example when we are using Ignition, but we have plenty of other possibilities in the marketplace. We will see the marketplace just in some minutes. So I will show all the possibilities there. Okay. Okay, so if no more question arises, let's continue. Anyway, please interrupt me if you have any question. Okay, I'll be happy to answer to you. So I will clear my filter. Let's go back to panel and let's see what are we going to do today. Okay. Once we have finished the unified namespace, let's have a look of how can we deploy a computer vision, okay, solution. This is one of our most demanded demos, okay, because it's really visual, okay, and it shows very well how can we work with video stream using Barbara and the Edge node, okay, in the Edge. So in this use case, what we have is a camera that is publishing a video stream, okay, using RTSP protocol, and we are going to read this data using an application called Video Reader that is available in our marketplace. This application basically reads the information from the camera and publish it in the MQTT broker, okay? So once we have the information, the video information in the broker, we will use a YOLO model, okay, from an application we have available in the marketplace from Ultralytics that basically analyze the video frame by frame and identifies different objects. Okay, so it can well, you can detect people, cars, trucks, traffic lights, different kind of objects. So it is going to make this analysis in the video. It will detect the object. Okay, so this AI model is going to generate a new video. Okay, a new video output and also a telemetry with all the information about all the patterns detected. Okay, both streams, the video and the JSON format telemetry will be published in a broker, and then they will be the video. We can visualize it using what we call the video player, and then all the telemetries in JSON format will be saved in an Influx database and visualize it using a dashboard from Grafana. Okay, so this is what we are going to deploy, okay? Not all the application here. Let me show you what we are going to do. We are going to use a video reader to get the information from this camera. The camera is a camera we have in our labs, okay? It is not a real camera. It's a simulated camera that is using a video from the street of New York, okay? But at the end, it's enough for what we need to do. This video is going to be published here in the broker. Then we will have the YOLO model here, publishing back a new video output and a telemetry. The new video output will be visualized here in the player, and then the telemetry will be saved in the InfluxDB database using the ingester, and then we will have the Grafana with the dashboard to visualize everything. Okay, so that is what we're going to deploy. All these applications related to video, the video simulator. Video simulator is useful when you don't have a camera, so you just need a video file, and with this application you can generate the video stream. Okay, for debugging purposes, it's excellent. Then we have the reader, the player, the encoder for changing the codec of a video if necessary, or for saving the video in any particular format, and then the recorder to record video stream. Okay, all these applications together make what we call the Barbara video tool. They are really, really useful, and all of them available in the marketplace. Okay, and well, all of them are available in the marketplace at the end. So let's start with this architecture. Let's deploy the broker, let's deploy the reader, and then the player. Okay, let's do that so that way we can use the player to see the original video we are going to work with. Okay, so let's go back to panel, and then let me show you. We are going to use this device. Okay, why? This is basically it's a virtual machine. Okay, it's a virtual machine in VMware. The good thing it has a GPU. Okay, so we can use the GPU to run this kind of YOLO model, vision model that run better when the GPU is available. Okay, so this is the GPU. We have here all the information about the GPU usage. Also in this telemetry, as you can see, we have the information about the RAM, the usage, and the temperature of the GPU. Okay, also. And let's move to this part in the application and model, and let's start deploying things. We are going to deploy, in this case, we will use the standard MQTT broker without a Sparkplug because of the simplicity of this use case. So I will just deploy it using default values. And now we have this broker available. Okay, so this is the way we can deploy an application to Barbara. Check how easy it is. We just need to select the application we want to use, the version, configure the parameters necessary, or leave the default one if you don't want to change anything. And now we have these cards indicating that we have the broker with the version, this version running, the status. We can stop and start the service, change any parameter after the installation if necessary. And here we can see the logs on real time of this application. Okay, so now we can see we have a local MQTT broker in this device. Let's add now the video reader solution. Okay, so I will just select video reader. Okay, with the version. Again, I have to configure different things. This is the configuration necessary to access the MQTT broker. And here is where I am declaring, okay, I'm going to read the video from this URL using RTSP format. Okay, so this is where I will be connecting to the video stream generated by the IP camera. Okay, then I want to name it this way, video reader 01, when I publish it in the MQTT broker, and I can set the quality, I can set the frame per second, this kind of thing. So I will send this application, right? I am deploying this application in the edge node, and if I see the logs, I will see that it has started, and okay, it is connected to the broker, and now it should be publishing information. Okay, so it seemed to be okay, connected also to the camera and reading the frames. Okay, so now what I will do is deploying the video player. Okay, so this way I will just configure the player to connect the broker. Now I can check that this player will be available in this port 5080, and here is where I will say I want to visualize the video that had this name, video reader 01, okay, which is one deployed or generated by the reader. So I will send this application, and as soon as this application starts, okay, I can check also in the logs that everything seems to be okay, subscribing and running. So now I can use this URL we have here. Just clicking here, I can access to this application. So I am seeing the original video. Is it the original video I'm going to work with? Okay. So what is the next step? The next step is basically deploying the YOLO model. Okay, check the YOLO model will be deployed here. It will read all the information from the broker. It will publish back the information to the broker. Okay, so let's review that. I have all the application here. I will collapse everything for having more space. And now I will add this Ultralytics application. And here we have for GPU. Again, the configuration for accessing the broker. And here is where I am saying, okay, I want to analyze this video input. Okay, this is the name of the video input I want to use. It is correct, video reader 01. Then this is the model I want to use for analyzing the video. Okay, in case um, this application also allows you to upload your own model, your own YOLO model, train it by finding specific thing, and this way you can configure the application to use your own model. Okay, so imagine you have been training a model for detecting smoke or fire or something specific. You can upload this model here also to the edge, and then you can change this name here to use your own model. So this is the same application. It's really, really useful. And now here we are declaring how is the name of the new video output we are going to use. Okay, and the name of the telemetry of we are going to publish also. Okay, so I send this application, and as soon as it install and connects, okay, we will start seeing the new video output here in the player. Okay, so let me refresh the view. Okay, and we will see that now, yes, we have this Ultralytics tab here, and it has started. It seems to be working right now. Okay, so well, if we go back to the player view, we will still see the old video, the original video. Okay, we need to change the player configuration to see the new one. So I need to change it and I say, okay, I don't want to see this video. Now I want to see this one, okay, which is the name of the video generated by the AI model. So I can say this parameter change, and as soon as the configuration applies or is applied, I will see the detection here in the video, okay? So it's taking some moments. Let me check it again. It was correctly applied. Yeah. Okay. It is taking some more time. Video player. Okay. Let me check one thing, please, before. Because I don't know exactly why I am not seeing the right. This is the demo effect we always have, okay? Anyway, let me check it again. I will just check in the Explorer, okay, that everything is running fine. Okay, so here we are. And we have, yeah, we have the video and we have the video reader. Okay, so yes, we have the video here. I don't know exactly why, how, here we are. Okay, fantastic. So it took longer than usual. I don't know exactly why. Okay, but yes, now we have this configuration chain. It normally take 1 or 2 seconds to apply, and today was slower. I don't know, slower. So anyway, we can see now the new video output with the detections of the different objects that it detects. Okay, so well, that is the new video output, and let's finish this use case just deploying the other part. Okay, we are also generating a telemetry. So let's save this telemetry in a local InfluxDB and then having a visualization dashboard. So we will deploy the InfluxDB, we will deploy this ingester to move all the information from here to here, and finally the Grafana. Okay, so let's continue. I will collapse everything, and then I will deploy the database. It's a real-time series database, very popular. I will deploy using default values. Now, once it has been deployed, I can check that if I enter here remotely, okay, I will be ready to enter in now, okay. So we will see that obviously there is no data in this database. Okay, here we can see that we have no data in the database. It's empty. Obviously, we need to deploy this ingester, which is the application that will be reading the information from the MQTT and sending it to the database. Okay, so I have to configure it. I will use a predefined configuration. This is also very interesting in Barbara because you can save your template, your configuration template, to be applied them to apply them later. Okay, so I'm just indicating I want you to read everything with just name in the MQTT broker, YOLO View 11 telemetry, save it in this bucket using this name. So when I send this application, okay, and it starts, when it has started, I can go back to my database, I can reload this page, and now I will see I have a YOLO View 11 telemetry here with the data being collected in this database. Okay, so final step, we will add the Grafana dashboard. Okay, and we will just include here a predefined dashboard exported in JSON format. Okay, so here we have it. Let's deploy this application, and once we have it deployed, we will see some data related to the detections. Okay, so we can use this IP to enter here. Okay, and this way we can access to the dashboard to see the information for car, person, traffic light, tracks, and the detection frame by frame in this lower view. Okay, so simple dashboard, but it contains all the information of the use case we have just deployed. Okay, so again, just an example of how to use it with computer vision, with a generic YOLO model. But well, it is really easy to understand how easy to use Barbara to scale this use case, okay? Because here, when we are using just one connector with one camera, it is really easy to add new cameras here in parallel and to provision all the information in the same broker. Or we can add more AI model in parallel to apply other detections, okay? And well, this is a really easy way to scale this architecture using one edge node, but also using more than one edge node, covering different areas or connected to different cameras. Okay, so well, this is the second use case I want to share with you today, this computer vision. So I don't know if we have any question, Juan.
No, Enrique, not so far. Nothing related to this part of the demo, the video.
Mhm.
But one thing that I would like to mention here, although you probably were going to do it anyway, is that you can, I mean, you all users can now create your own account for free. There is a, a landing page where you, exactly that one, I will paste it anyway later in the chat, where you all can create your own account to try this out. And we have some tutorials in Academy that explains these two both cases that Enrique has just followed, the one related to the operations or UNS, and the one related to computer vision, you have tutorials to guide you in doing exactly the same as Enrique has just done. So feel free to, after this call or whenever you have time and the will, try it out, and you will see with your eyes, with your own eyes, how you can do it. That's all,
Okay,
Enrique. You can go on.
fantastic. So we will provide later this URL so you can get your own trial license. So this third part in the presentation is the tech section is just showing you an overview of the platform. We have seen how to deploy a couple of use cases. Now let's go a step lower and let's see how the platform is. What are the things we can do with the platform? Okay, point by point. So I will start showing you the way of. I want to start speaking about the hardware compatibility about Barbara, and also how is the process to provision new devices in the platform, because it is really easy. Okay, so let's start from this point. Okay, um, let's go here and we can go to this part, the OS images, where you will find all the version for the Barbara core we have for all the different hardware that are compatible with Barbara. Okay, you can see it also then here. These are the edge node or edge devices we are compatible with, from very small and basic devices like our Raspberry Pi to the most complex industrial server from the well-known vendor like Schneider, Dell, or the Advantech, if any contacts with other. We have also devices that have GPU, like for example the NVIDIA Jetson Nano or Orin. Okay, and not only physical devices, we have also compatibility with virtual machines. Okay, so at the end, when we are speaking about edge devices, we are compatible with any equipment that is based on Intel or ARM architecture. Okay, so that means that this list is continuously evolving depending on our user needs. Okay, but we can port our OS to any of these devices. Okay, and when we are speaking about virtual machine, we can handle virtual machine for VMware or KVM or Hyper-V. Okay, so we have also plenty of options to use them. The process to provision one new device in the platform is really simple. Okay, and that is one of the reasons why we have a specific OS per device, as you can see here. Okay, we don't have a generic OS for all the devices. We have created a specific OS per device because we want the installation of the firmware to be as simple as possible. There is nothing to configure. Everything is ad hoc. Okay, so you don't have to know what is the characteristic of your device, or no, you don't have any option in the installation. You just need to select the equipment you want to use, for example, this Advantech equipment, download here this OS, okay? You will have the option to download the OS to your platform, to your laptop, and then you put this OS in a USB, plug it to your equipment, and install it there. After the installation process, you will get an ID in the display, okay? So with that ID, you just need to go here and add a new node indicating the ID. That is the only thing you need to do. Okay, so get the ID, put it here. You will have one new edge node in the Barbara platform. So the installation and the provisioning process is really simple. What else we have here when we have been speaking about provisioning new devices? Okay, let's speak a little bit about the Barbara core. Okay, we have here all the functionalities about cybersecurity. I mentioned some of them before. Okay, but once you have this firmware running on your equipment, you will see that it is like a black box. You cannot do almost anything with that directly. You need to use the device through panel. Okay, not you cannot connect a keyboard and a display and start sending command to this equipment. It is not working that way. Okay, you will see that you have no root access. Okay, so you cannot access you cannot access the device using SSH, using Docker. No way. Okay, you cannot access the device this way. There is also no user password access. All the ports are closed by default. Okay, so the device is completely hardened. Okay. absolutely no incoming communication channels. Okay, so all the communication channels are all solely outgoing and secure, and it is not allowed to have incoming channel. We have also file system isolation. We have full data encryption. Okay, we have an unmatched identity management using that ID, so it creates unique certificate per device, cryptographic certificate, so the authentication authorization mechanism is really, really robust. Okay. Then we have also secure boot, the trusted provisioning, TPM support, and secure and signed OTA update. Okay. We will see how to can we update our device in panel. Okay. So all these are the functionalities, the cybersecurity functionalities that are included in the OS after the installation. Okay. So let me show you the basics about the device management, okay, and then I will show you how can we, for example, upgrade the firmware of the equipment, this kind of thing, okay. When we enter in one device, for example, this one, we have this view, the node information view, where all the information about the parameters of the device are available, organized in cars, okay, but we can see, for example, the device we are using, the location, the timing. We have also information about the telemetry with the health of the device on real time. Okay. We can see also the network card where we have all the information about all the network interfaces available in our equipment. Check, for example, we have here four Ethernet interfaces, one mobile interface. We can enter in any one of them and start managing them. Okay, changing any configuration necessary. We have also the possibility to use the VPN. We used it before, but also we can also establish proxy communication. Okay, we can enable a proxy for securing normally the connection between the edge node and the cloud. And we can also configure the IP table of every equipment one by one. Okay, so we can do a lot of things here related to the hardware itself. Apart from that, we have also some cards related to the Docker management system. Okay, at the end, every application, every AI model we are deploying on the edge is based on Docker containers. Okay, so we have here the information about the volumes. The volumes are like the folders, let's say, where Docker is saving the data, because we have the containers and the data in a volume, so they are not in the same place. That way we can update any application without losing our data. This is very important. Okay, that is why we are using this volume to persist the data in the edge node. Okay, so we can see here, for example, how many volumes have been created in the edge node, the size. I can see, I can delete it, or I can get all the information about them. Okay, I can also declare secret or variable like environment variable. Okay, that have been declared in the edge node, so they are accessible by the applications, okay, and they are saved in a secure way. That is why they are called secret. And we have also the possibility to declare credentials. Okay, why? Because we can also deploy not only marketplace application. Okay, we have the possibility of deploying marketplace application. We will see the marketplace in just 1 second, but we can also deploy what we call Docker or user Docker application. Okay, so the customer can add a new application just uploading here the Docker compose file, and the Docker compose file is like the manifest of the application. Okay, where you are declaring what image do you want to download, how to create the container, this kind of things. Okay, so these images are normally stored in repositories. Okay, if the image is in a public repository, there is no problem. Okay, but if you are saving your images in a private repository, you need to give the credential to the edge node to access this repository and download your image. Okay, so that is why we have this here. You can set here the URL of the repository, the username, and the password. So this way, the edge node can access to this private repository to download the images. Okay, so it is also available here. Well, we have alerts and notification indicating some event that maybe that may taken into account. Okay, and well, finally we have here the possibility to update the firmware of every device, okay, to keep them secure. and obviously manage the life cycle and pruning images containers from some option for Docker, or even restarting the Docker daemon. Okay, so this is related to the hardware itself. Let's move to this application and model part. Here is where I can deploy what I mentioned before. Applications uploaded by the user, AI models also uploaded by the user. Okay, the user can also upload any model, train it by himself. Okay, so they just need to select the framework they have used to train the model, select the engine they want to use to serve it, upload the model in a zip file, and this way we can deploy that to the edge node. Okay, but apart from that, from use custom application and custom AI model, we have all the possibilities available in the marketplace. Let me show you the marketplace. So here is where we will find all these pieces that will help us to make everything quicker, okay? Because we will find different categories starting in industrial, for example. In the industrial category, we will find all these kind of connectors. We need to read data from any existing equipment, okay, using protocol like OPC UA, as we did before in the UNS solution, or Modbus, or BACnet, or Profinet 2.7, okay? So we can see here BACnet, we can see here the Modbus, but we can see also OPC UA application to integrate this data, to move this data to other third-party systems, like for example, Litmus, Neuron. We have also Ignition here. We have HiveMQ, AMQX, a lot of different third-party systems. So we can read the information, we can send them there, and not only to this third-party system, also to the cloud. We have connected to Azure, we have connected to other AWS, to Aviva. So a lot of solution to read data and move data to somewhere else, okay? But we have also the storage category that contain all these kind of databases that can be deployed on the edge node to store the information locally. You will find also analytic tools to analyze and process and visualize the information in the edge node. You will find also AI models and AI tools that will help you to work with AI in the edge node. So, for example, Jupyter Notebook. For example, we have here LLM model, MLflow or ML server. We have also this video computer solution or computer vision solution we have used in the use case, all of them here, NA10, REN AI, a lot of different possibilities to work with AI model. And finally, we can also deploy virtual machine. That is one of the latest features we have in the marketplace. We can deploy a complete virtual machine on top of the edge node. So, well, as you have seen, we can just select all the pieces we need to use and configure them to create a data flow from the sensor to the database, then the processing, then the visualization dashboard, then sending the result to somewhere else. Everything is possible using Barbara. Okay. So, well, this is what I wanted to show you about the possibilities of application that can be deployed. And let's speak about a couple of things, okay, and then we will finish with this overview, okay. Well, I want to show you, we have been working with a single edge node all this in all this session, okay. But one of the most powerful thing about Barbara is that you can manage a big fleet of devices all together in a single click, okay. That is why we have this batch command wizard. It's basically selecting as many edge nodes that you need, okay, or you can use group sample, okay. I imagine we have this UNS group we see before, and I say, okay, I want to select all these devices in this group, and then what I want to do is, I don't know, I want to reboot them, or I want to change any configuration parameters to all of them together, or I want to install any application or to update one of the applications they are using, okay? So I can do everything here in a single click, okay? So, for example, if we go back, we can select all the edge nodes available here and imagine I want to, I don't know, deploy an Apache NiFi application, for example, okay? So check, I am deploying this application into 18 X nodes in a single click even if some of them are offline. Okay, I have a couple of equipment here that have no communication with panel right now. They are offline, but it's not a problem. Okay, I can send the command, and as soon as these devices get connectivity again with the platform, they will receive the command and they will apply it. Okay, so we can handle this kind of asynchronicity between the edge node without any problem. Okay, so this is very easy to manage big group of devices all together to be sure that you are using the same version for your application, the same configuration, to keep them updated in a single click. Okay, so it is what we call the batch commands, really powerful. And I want to speak a little bit also about the clusters, okay, or what we call the high availability functionality, okay. So what is the key here? When you deploy in a service to a customer in the industrial world, normally they want the service to be running without interruptions, obviously, okay? They want it to be running 24/7 without downtimes, okay? In order to guarantee that, we cannot rely on a single edge node because if we deploy an application on top of one edge node and the edge node have any problem related to hardware, power supply, or whatever, the service will be interrupted, obviously. Okay, so that is why we need some redundancy. We need to use several edge nodes together. Okay, and that is exactly the definition of a cluster. Okay, I can create a cluster here composed by different edge nodes. For example, here, I think that I have 3 nodes that are working together, creating this cluster. Okay, so you have 1, 2, and 3. Okay, and the cluster has a couple of characteristics really useful. The first one is this, the virtual IP. Okay, I can set a virtual IP, a unique as a unique entry point for this cluster. Okay, so no matter how many devices are in the cluster or the IPs they have, I can use this virtual IP to access the service no matter where they are. Okay, so it is a really, really necessary feature. Okay, the other one is the volumes. Okay, I can create shared volumes. Okay, in the same way I had volumes in the edge node, now I have a volume at the cluster level. So all the data is in this cluster volume, and the volume is shared among all the nodes that belong to this cluster. Okay, so this way, when I have this cluster created, I can go here to the application and model, and I can see that I can deploy applications on top of the cluster in the same way I did for a single edge node. Okay, so I have a MySQL application, I have an Ignition server, and I have a Node-RED running here. Okay, check the if I go back here, I will see that I have this has the Node-RED application is in the node 1. Then I can see that I have the Ignition in the node 2, and then I can see I have the MySQL in the node 3. So we have one instance per node. Okay. What I am going to do now is simulate the fact. Imagine I need to update the firmware of this edge node number 3. Okay. If I update the firmware, I need to reboot my device. Okay. And that will obviously mean that I have some downtime in my service. Okay. So what I will do in this case is just saying, okay, I will drain this node. Draining a node is indicating the node, okay, I'm going to install you a new firmware. Please move your workload to all other available node in the cluster. Okay, so I will just drain this node, and I will see that this application will move to one of these devices. Okay, I don't know which one. We will see in some second. Here we have it. Okay, so now the MySQL is running here, and in some second this disappeared from here. Okay, so now what is happening is that the service MySQL has moved from this node to this one, okay, without having any downtime. So I can enter again to this application, and the data and the application has been moved to other of these available edge nodes. So check, we have nothing running here now in this node, but I have this two in this one. So now I can imagine I update the firmware of the device. this reboot, and after the installation process, I will just activate again this node, and probably the application will go back here. Okay, so this is in case I need to perform some kind of programmed update or whatever. In the case that the device has any problem and it is down, this is automatically done. Okay, so the application will move automatically without the need to press drain or something like that. Okay, so this is the way of working with clustering. You can see the process to deploy an application to a cluster is really, really simple. Let's deploy, I don't know, Grafana, for example. Okay, so you just need to configure everything in the same way we did before. Okay, but now we have this part here where we are indicating how many replicas do we want to deploy. Okay, in the example I have shown you, we have one replica per application, but we can also select two or three or as many replicas as I want. Okay, so this way we will have several instances of the same application, each one running in different devices, so it makes everything even more resilient. Okay, so well, all of this is configurable, and as you can see, really, really powerful. Okay, to provide this high availability service. Just to finish, showing you one of the latest screen we have, this dashboard. We have not seen it before. It is a good way of seeing in a simple site the main aspects of your organization with the number of nodes, how many of them are offline, how many of them are updated, and they need to receive a new version for the firmware, how many nodes, how many of them are stopped, how many of them are updated and they need a new version, okay, the number of clusters, the healthy ones, the telemetry alert, all the information here that makes um, or help you to understand how are things behaving in your organization in a simple site. Okay, and at the end we have here, for example, the most used application in this organization, the hardware, all the information is here. This is one of the latest um, views we have published in the Barbara panel. Okay, so well, I think that is this is a good overview of the possibilities of the platform. I don't know if we have any question in the chat.
No, I was just reviewing it. No more questions. I hope that is because of the good explanations you have carried on. So anyway, I have shared in the chat a link to our academy so everyone can take a look on the documentation we have over there that explains in depth all these functionalities and also provides these two tutorials so people can follow the same deployment that you have just shown us. And I think that would be all right from your side. It's already
Yes.
you have covered what you wanted. Before we leave. I would like to remind everyone that we are going to, or they are going to see a couple of questions once they finish they will have a survey when they finish this call. Please just give us your feedback. Your honest feedback is extremely valuable for us so we can improve this kind of sessions. So tell us what do you like, what you don't like, and what else you would like to see in this kind of webinars.
Exactly.
Okay, so thank you, Enrique, for your time and your explanation as always. And thank you, everyone, all the people that attended and stayed with us the whole 90 minutes that we were here. Hope to see you next time with more new features and more new use cases.
Thank you, everybody. Okay.
Goodbye, everyone.
Bye
Bye.
bye.